Especially in the field of mechanics of materials, we typically face the problem that we are rarely able to determine all material properties from one product only. This is simply because most methods to determine such material properties are either destructive or computational in nature. Hence, we are forced to establish relationships between the actual product and a completely scattered set of separately determined material properties. Because of the complexity of those relationships, the history dependence of the material properties, and the heterogeneity of materials data in general, data processing and management is typically treated in a problem-specific way. So from my own experience, this has one major drawback. Once the way of looking at a problem changes, then usually data processing and structuring starts all over again. And this is not only annoying, but also extremely time-consuming, expensive, and error-prone at the same time. So, in order to solve this general problem, we have been working on a data space concept, which means that we describe the processes and material history with a knowledge graph. In order to define which types of nodes and edges and which combinations thereof are permitted, an ontology is used. One huge advantage of directed knowledge graphs I see is the rather natural representation of process chains and the resulting traceability, which almost comes automatically. In the past, we have worked rather intensively on the development of software tools and a digital workflow. This digital workflow allows the user to structure arbitrary processes and the associated data according to the knowledge graph concept, and finally to also store the data in a graph database. In the future, we will focus on graph and process chain specific queries and the development of application specific ontologies. The next big challenge from my point of view is to guarantee the scalability during ontology development, which means we have to deal with multiple domain specific ontologies and the question how to merge them together.